let's start with the ideal gas law. This is arguably the most important gas law, which we have PV equals nRT. The ideal gas law helps us understand gases under ideal conditions, when gas molecules aren't too crowded and don't interact much with each other. So let me provide an example. So let's say you have 2 moles of gas at a temperature of 180 M and a temperature of 300 Kelvin. Now the question is, what is the volume of the gas? Using our formula PV equals nRT, we are going to use the cancel out method to find the volume. Since we are going to find our volume, we need to put P as our denominator in both sides. So after we cancel it out, we are left with volume equals nRT over pressure. After that, we are going to put their values, so it should be 2 moles and our R is constant, which is 0.082180 M per mole dot Kelvin, and RT, which is the temperature, and so it's 300 Kelvin. So over our pressure was usually in ATM, which is 1. So when you are done substituting the known values, we are going to perform the calculations. So now our answer would be 49.26 liters. Now let's explore gas density. Remember, density is mass per unit volume, so we can calculate gas density using a modified versions of ideal gas law, which is density equals P times M over R times T. We're going to give you an example, which is what is the density of oxygen gas, or O2, when a smaller mass is equals to 32 grams per mole at 180 M and 300 Kelvin. So in order for you to solve that problem, we are going to use our formula, which is the density is equals to P times M over R times T.
Charles' law states that at a constant pressure, the volume of gas is directly proportional to the temperature. In simple terms, the volume increases, the temperature increases too, and vice versa. Think of it like a balloon. When you heat it up, it expands. When you cool it down, it contracts. That's Charles' law in action. So the equation for Charles' law is V1 over T1 is equal to V2 over T2. Just remember to use.
Okay, next is the Gay-Lawson slope. Say that when the pressure of the gas increase, so its pressure also increase if the gas is in a closed container. So if the temperature goes down, also the pressure goes down. Just like for examples, if a gas in a sealed container has a pressure of 150 kPa at 20 Celsius, so if a gas is heated at 80 Celsius, what will be the new pressure? So we'll assume that the container volume does not change. Okay, here's the given, which is the P1 is equal to 150 kPa, and the T1 is equal to 20 Celsius, and the T2 is equal to 80 Celsius, and what will be the P2? So T1 is equal to 20 plus 273 is equal to 293, and the T2 is equal to 80 plus 273 is equal to 393. Okay, next as it's solved for the P2, which is the P2 is equal to P1 times T2 over the P1. Let's substitute and compute. So the P2 is equal to 150 times 353 over 293. So let's divide that. So it's equal to 1.205. Okay, next is the P2 is equal to 150 times the equal of the T2 and the T1, which is the 1.205. So that will be a 180.7 kPa. So the final answer is the 180.7 kPa.
Avogadro's law. Hello everyone. Today, I will explain Avogadro's law. So, Avogadro's law states that at constant temperature and pressure, the volume of a gas is directly proportional to the number of moles of gas. Then, this means that when you add more gas particles, the volume increases. When you remove particles, the volume decreases. This happens because gas particles move freely and more particles need more space. For example, suppose a gas has a volume of 2 liters when it contains 0.5 mole of gas. If we increase the amount of gas to 1.0 mole and keep the temperature and pressure the same, the volume also increases. So, using Avogadro's law, V sub 1 is the initial volume over N sub 1 is the initial number of moles equals V sub 2 is the final volume over N sub 2 is the final number of moles. So, 2.0 liter over 0.5 mole equals V sub 2 over 1.0 mole. So here, we are trying to solve the V sub 2. So the answer is V sub 2 is equals to 4 letters. So that's all, and thank you for listening.